In this video, we're going to talk about evaluating inverse sine, cosine, and tangent functions. So what you need to remember from the reading material is that sine, cosine, and tangent are not one-to-one functions. So we need to make sure that we restrict the domain on sine, cosine, and tangent in order to speak about the inverse sine and the inverse cosine and the inverse tangent. So the restrictions are different for each one of these trig functions. For the sine function, we are going to restrict our domain from minus pi over 2 to pi over 2. So when we're evaluating an inverse trig function, like this first example where we want to find the inverse sine of the square root of 3 over 2, what we're being asked to find is the angle where sine is the square root of 3 over 2. So that means that we want to give an angle answer here. But the angle that we give has to lie within that interval from minus pi over 2 to pi over 2. So if you think about what that means in terms of the unit circle, on the unit circle, we are going to speak only about the angles that lie in the first quadrant from 0 to pi over 2, and in the fourth quadrant from 0 to minus pi over 2. So in the first quadrant, we are going to move in a counterclockwise positive angle direction. And in the fourth quadrant, we'll always be moving in a clockwise negative direction. So if we look at the first example and we ask ourselves, at what angle is sine square root of 3 over 2? Well, we know that sine is positive above the x-axis. So that means the angle that we're going to pick is the angle from the first quadrant where sine is the square root of 3 over 2. And that, of course, we know is a standard angle of pi over 3. So the inverse sine of the square root of 3 over 2 is equal to pi over 3. We're just finding which one of those common angles we want to use for our result of our inverse based on this real number that we've been provided. So if we move over to example number 2, we're being asked here to find the inverse sine of negative 1/2. And again, I'm looking for the angle that appears in either the first or the fourth quadrant. So since sine is negative, since my real number here is negative, I know that I'm looking for an angle in that fourth quadrant below the x-axis. So I want to make sure that I rotate from the positive x-axis in a clockwise direction until I get to that common angle where sine is equal to negative 1/2. And I know that that angle is located at minus pi over 6. So keep in mind, if you're looking at your unit circle, typically that angle over here in the first quadrant is listed as 11 pi over 6 with a cosine value of square root of 3 over 2 and a sine value of negative 1/2. But remember, we can't use that angle 11 pi over 6 because we're forced to give an angle in that interval from minus pi over 2 to pi over 2. So we don't want our rotation to go in the counterclockwise direction from the positive x-axis all the way over to that terminal side. We want the angle that goes in the clockwise direction but still gives us that same terminal side. But then that gives us an angle which fits in that allowed interval. Now if we go and talk about cosine, cosine's restriction on domain is a little bit different. Cosine has a restriction on the domain of 0 to pi. And that's all based on what that graph of the cosine function looks like. We want to restrict it so that we get all positive and negative values of cosine and still have a portion of that graph that passes that horizontal line test. So the same idea applies when I go to find the inverse cosine of square root of 2 over 2. I'm looking for the angle whose cosine is the square root of 2 over 2 but I need my angle to be between 0 and pi. So again, if you think about the unit circle, we're looking at only the angles that appear or that occur from the positive x-axis all the way over to the negative x-axis. So we want angles in either the first or the second quadrant. So in this example number 3, cosine is positive, and we know cosine is positive to the right of the y-axis. So that means we're looking for the angle that is in that first quadrant whose cosine is square root of 2 over 2. And that's that common angle of pi over 4. So always make sure when you're giving a response to an inverse trig that we always make sure that this angle we give as our answer fits in that interval for my restriction on my domain. Example number 4, we've got the inverse cosine of -1/2. So in terms of my unit circle, cosine is negative to the left of the y-axis. So that means I'm looking for an angle from the positive x-axis to an angle within that second quadrant where the cosine is -1/2. And we know that's a common angle of 2 pi over 3. So again, because we're talking about this first and second quadrant from 0 to pi, my angles are always going to be in the counterclockwise positive direction. So I should be giving positive angle values for these inverse cosines. On to tangent. When we move to tangent, again, we have a different restriction on what that domain is allowed to be. So for tangent, we know that our domain must be restricted to -pi over 2 to pi over 2. Now it's similar to sine. If you recall, sine was a restriction of domain from -pi over 2 to pi over 2, but we had brackets. So it included those two quadrangle angles. In terms of tangent, we want to take out the -pi over 2 and pi over 2 because we know that on that angle to pi over 2, tangent is undefined. And if we drop down to -pi over 2, at -pi over 2, tangent is undefined. So we are again talking about the first and the fourth quadrant, but we're not allowed to use -pi over 2 or pi over 2 as an angle. So the same idea again applies. For the inverse tangent of 1, I want to find the angle whose tangent value is 1. Now it helps to remember because tangent isn't always something you memorize as quickly as you do the sine and the cosine, but just remember the relationship that for the tangent of an angle, that is the ratio of sine to cosine. So we know that sine and cosine have one of 3 common real number values within the quadrants: 1/2, square root of 3 over 2, and square root of 2 over 2. So we know that if we're looking at square root of 2 over square root of 2, tangent is equal to 1. If we're looking at sine over cosine, where sine is 1/2 and cosine of my angle is square root of 3 over 2, that simplifies. The two denominators divide out and I get 1 over the square root of 3, and rationalizing the denominator gives me square root of 3 over 3. And I'll show you where I'm going with this in a minute. And we also know that the third option for tangent is if I have the sine value of square root of 3 over 2 and cosine value of 1/2, then the 2's divide out and I get a tangent value of the square root of 3. So for getting SIGNs, positives and negatives, these are the typical 3 tangent values that I'll be evaluating for inverse tangent. So when I look at this example of the inverse tangent of 1, I know that I'm looking for this ratio here. I'm looking for the angle where tangent is 1, which means sine is square root of 2 over 2, cosine is square root of 2 over 2. And I know that I'm looking for a positive value of 1, so my SIGNs have to be the same. Now again, if I'm looking at only the first and the fourth quadrant, sine and cosine and tangent are only positive in the first quadrant. So I'm looking for the angle in the first quadrant where tangent is equal to 1, meaning sine and cosine are both square root of 2 over 2, and we know that that angle is pi over 4. Now hopefully you'll start memorizing tangent as well as you have sine and cosine. But until you do, you can always make yourself a little cheat sheet for tangent by using that ratio of sine to cosine, since you should know those quite well by now. Last example, we're looking at finding the inverse tangent of negative square root of 3. So remember down here where I've done my little cheat sheet, we're looking for a version of that one. So we're looking for a version of where sine is square root of 3 over 2, cosine is a half, but because this is negative, I want those SIGNs to be different. So in terms of quadrant, I have first or fourth quadrant to look at. Sine and cosine are different SIGNs only in the fourth quadrant, where sine is negative and cosine is positive. So I'm looking for an angle in that fourth quadrant where sine is negative square root of 3 over 2 and cosine is positive 1/2. And we know that that angle is equal to minus pi over 3. And again, remember that the terminal side that we draw in that fourth quadrant, when we go to list the angle for that terminal side, we always want to list the angle from the positive x-axis in the clockwise direction, negative direction, to that terminal side. So we want the angle minus pi over 3 because that's the angle that fits in our allowed interval.